So I think we'll try another one of those. I managed to find one, a nice one from an OCR paper to practice with. So it's this last one here. It says the standard enthalpy change of formation of hexane can be determined indirectly. Calculate the standard enthalpy change of formation of hexane using enthalpy changes of combustion below. So this time it's slightly harder because they haven't given us the equation, but they have told us what they want us to calculate it for. So they're trying to get us to work out the standard enthalpy change of formation of hexane. So what we need to write an equation which represents the chemical change that takes place there. So hexane, C6H14. It's a formation, so we need carbons and we need hydrogens. Hydrogen is a diatomic gas, carbon is a monatomic solid. Is being used to make hexane, which is a liquid. So I have hexane as a liquid there. So back to the question. It's the standard enthalpy change of formation of hexane, so the enthalpy change for this reaction can be determined indirectly, so indirectly using Hess's law. Calculate the standard enthalpy change formation of hexane using this data here, so using the combustion data. So what is the combustion data doing? Is burning the carbon and the hydrogen to make carbon dioxide and water, and it's also burning the hexane to make carbon dioxide and water. So this is the delta H that we want to find. This is going to be delta HB, and this is going to be delta HC. I've just randomly assigned the symbols. So if we go back and we work out the equation for delta HA, so delta HA, so going from here to here, is the same as going along this arrow and then against this arrow. So it's the same as going plus delta HB and minus delta HC. If we work out delta HB, so what's going on in delta HB? 6 carbons are being burnt and 7 hydrogens are being burnt. Every carbon that gets burnt is minus 394 kilojoules per mole, and every hydrogen that gets burnt is minus 286 kilojoules per mole. So delta HB is 6 slots of the minus 394 for the 6 carbons and 7 lots of the minus 286 for the 7 hydrogens that get burnt. So if we work that out now, gives us minus 4,366, and in delta HC we're burning 1 mole of hexane. So for every mole of hexane that gets burnt, minus 4,163 kilojoules per mole of energy. So one of these is minus 4163. So we've now got delta HB and delta HC. So delta HA is going to be delta HB, so plus delta HB, which is 4366, and it's a minus value, and then minus 4163. So if I get those numbers in, gives me minus 203 kilojoules per mole for this reaction. And they always work the same way. So if they ever ask you to work out an enthalpy change indirectly using combustion data, the setups that I've shown you there are how you do it. Another sort of way they could ask these questions is something like this. So it says calculate the standard enthalpy change of the following reaction. So we've got these 2 reactants, and then there should be an arrow again reacting to make these 2 products. And instead of giving us combustion data, so instead of giving us delta CH this time, they've given us delta FH, so the enthalpy change of formation. So let me just move my paper, get a new piece of paper. So there's my reaction. So I've got Y2O5 as a solid, reacting with that, and it's making I2 as a solid and 5 CO2s as a gas. And they've asked me to work out the energy change of that reaction there. So let's call it delta HA, and that's the one they've asked me to work it out for. But this time, instead of giving me combustion data, they've given me formation data. So enthalpy change of formation is the enthalpy change that takes place when 1 mole of a substance, so maybe in this case I2O5, is formed from its constituent elements, so iodine and oxygen, in their standard states under standard conditions, and that's the energy change. So this value, let's just focus on this one here first, minus 158 making I2O5, is the energy change of going to make this from iodine and oxygen. Iodine is a solid and oxygen is a gas. We need to balance it, so we've got 2 iodines and then we've got 5 oxygens here. We'll sort out the oxygens in a little bit because we've also got oxygens in this one. So the energy change to do that is minus 158 kilojoules per mole. We're also given the value for carbon monoxide, so CO. So constituent elements here, oxygen, we've already got oxygen down there. We've got carbon as well, so plus carbon as a solid, and we've got 5 of them. So now we can balance the oxygens as well. We've got 10 oxygens in total, so 10 there. So if we call this one delta HB, and these two values here are giving us the changes that occur, and then going along this way, so to make iodine as a solid, from iodine as a solid, there's no energy change, so they don't give us the value, which is 0. And to make 5 lots of carbon dioxide, for every mole of carbon dioxide is minus 394. So we can go take the arrow that way this time to represent the energy changes that occur there. So when they give us this data, delta HA, so going from reactants to products, is against B, so minus delta HB, and then plus delta HC because we're going with that arrow. So if we try and work out delta HB now, what's happening in delta HB? We're making 1 lot of I2O5, and to make an I2O5, paper keeps moving, to make an I2O5 is minus 158. So delta HB is minus 158, and then we're making 5 carbon monoxide, so plus 5 lots. You can see carbon monoxide on the screen, minus 110. So 550, 650, 708. So the energy change going along here is minus 708. Let me just check that, so I don't want it to go wrong. And then delta HC, so going along this arrow, we're making iodine as a solid from iodine as a solid, so the energy change for that is 0. But we're also making 5 lots of carbon dioxide, and every bit of carbon dioxide we make, the energy change is minus 394. So 5 lots of minus 394 will give us minus 1970. So overall energy change for this is minus delta HB, so minus 708, plus delta HC, which is minus 1970. So if we plug those numbers into the calculator, we will get minus 1262 kilojoules per mole. So that's the other way they could ask you to work out